Well, hi, good morning, and welcome to my shop. I'm a little more optimistic this morning. So I've been chasing a pop and a click in this radio. If you've been watching the series, you know it's been along for the ride all the way through the work I've been doing here. And I've gotten down to the point where I think it must be the number 27 tube. And this has been a bit of a confusing trip trying to sort this out because I've had a couple of indications that it can't be this tube. So for instance, I have a replacement which I put in and the popping went away. Or did it? No, it didn't. Yes, it did. No, it didn't. So I got to the point now, after fiddling around, if you put this tube in, the radio pops. You put this tube in, the radio pops almost identically, which makes you think it can't be the tube, it must be something else. But I've essentially eliminated everything else. I believe I have anyway. And I'm back to suspecting now that both of these tubes are similarly defective. That's a bit of a long shot conclusion that you would have two tubes with a similar defect in them like that. But maybe this is something characteristic of this particular type of tube. This is an early tube, one of the earliest to have a cathode in it. It has 5 pins, an extra pin for the cathode. And perhaps its life was short, and perhaps there's something about the cathode in the heater that leads to this popping. Maybe there's something. So anyway, it's really disappointing to me because this is all I've got, or the original 27, my own spare 27. This morning I went through my tube collection again, tube by tube by tube, at least this vintage of tube, and look at that, I found another 27. I have another 27. So we're going to start by testing this guy in the tube tester and then put it in the radio after we test it in the tube tester. So let me get that all set up here. Wow, it's a new, so it could be I'll put that third tube in, there'll be no popping, and I'll be able to conclude the first two tubes were defective. So, well, yeah, that's what I hope. We'll see what really happens here. Okay, so if you're hearing some low rumbling, that's road work going on in front of my house. Our street's being paved this morning. So number 27, I think we're all set for that. It has a 2.5 heater voltage, and it draws almost 2 amps. I think it's 1.75 amps. So this is actually a pretty hungry filament here for current. JR3232204. Okay, 204 with a 041. 49. My whole house is shaking here. 630 reject point. 1000 is a good one. Okay, I think we're set here. Pop it in. Come on, heat up. Yeah, it's heating up. Excellent. Boy, I hope this works. Test for shorts. Watching the short light. That's a very good sign. Number 27. 630. So 3000 scale. 630 is just above where my finger is now. There we go. Hot diggity dog. Look at that. Okay, so we've got a working tube now. 1000 is way up here. It's still rising very slowly. It's probably still heating up a little bit. But the point is, we've got a tube. I think this one tests better than either of the other two. So a big thumbs up. Looks like 750 in the end. Great, because one of the other tubes was below 630, the reject point, and the other one was only a little bit above. Hot diggity dog, it's a new day in the shop here. Okay, let's stick it in the radio. Let's see what kind of result. Wow, there's stuff vibrating inside my shop here now. From that big machine. Hey, you want to see some scared cats? You should see my cats today. They are scared. Now wait, should we get this thing popping and then put it in? Yes. Let's not mix up these tubes here too. Pretty easy to mix them up. That's a Westinghouse. I'm going to put this. Oh, this is the original. This is the original. This is my replacement. Let's start with the original. Scare me there. You might see some connections made. I had initially intended on getting more information, so I thought, well, I'll scope some of the signals that are on this tube, and maybe that'll provide some insight. That's how desperate I was getting here. Okay, let's just see if we can't. We're ready. Volume down, antenna connected. Let me just take this off here just to be sure that these can't, you know, just in case. Okay, there we go. Hit the switch. Please pop and click. If it doesn't pop and click, volume up a bit, full power. Just popping and clicking. Okay. So out with the original. Oh, holy jeez, did I get on camera? I almost dropped this poor guy on the floor. This is my new one here, 27. Here we go. Well, I have to turn it on yet. Okay, what are the odds? Okay, I'm going to put the odds of this fixing the radio. That in fact I have two popping 27s. I'm going to put the odds at 80% that that's really what's happened here. Okay, we're off to a good start. Here we go. Well, so much for my 80% guess, eh? Wow. Okay, so it's a hum in there too, on this one. Not microphonic. Different support structures built in them, made by different manufacturers. Okay, well, no question about that. That's I don't know whether to say that's disappointing or not. So what are the chances I've got three tubes that all behave exactly the same? It's really, really low. So we're back to square one here. Something makes this radio pop, and it's not the 27 tube. I think that's the conclusion I have to accept at this point. And what's left here? I really, son of a gun. I don't know. What's left is for me to spend a little more time thinking here about this. It's a beautiful day here. You know, I really don't even want to be in the shop today. I only get so many beautiful days in the summer. So, but I'm going to go away and think about this. Yikes. Okay, so I went away for an hour or so to kind of lick my wounds on the not really surprising fact that three noisy tubes. No, that can't be the case. It just can't be. There's something else going on in this radio. and I haven't really got a clue at this point what it is now. So I'm going to go back to what I was originally going to do, and that's just do a couple more tests, get a little more information. So in order to do that, I've hooked up my scope. You can see the scope leads here. They're just connecting to the available pins underneath the socket on this tube. One is hooked up to the plate circuit, and the other one is hooked up to the grid. Let's see, the blue one is the grid. The blue one, so this lower line. Oh, you can't see that, can you? Well, I can just tip this up for now. Okay, so the lower line, which you can barely see, is the grid, and that's the plate. Did I get that right? Blue is the grid. So yeah, grid, plate, signal. I'll make this just a little more visible here. There, you get a good look at the two lines. Let's see, the scope is set for 5 volts per centimeter, both channels, and set to DC. So we'll see what happens when we switch it on here. Switch on the radio. Yeah, there's not much to see with the radio itself, so I'm just going to leave the camera on there. And first whack the microphone here, and then I'm going to power up the radio. Whoosh! So one has disappeared off. That's the plate. So the plate voltage around 45 volts. That would be, 5 volts per division. That's way off. I can't make them less sensitive. So we're just going to have to wheel it back down here. Oh, look at that. Isn't that interesting? That's really interesting. So I'll make the grid one more sensitive too, because grids are like that. I'm going to flip this to AC. I'm going to flip this one to AC also. Where'd it go? Should have just floated down to here. Oh, because I had adjusted the position. Yeah. Okay, flip it to AC. Okay, I think we're ready now. Let's listen to this thing. Why so quiet? Oh, we're still on. So it's popping, but in fact I'm still on the dim lights. You can see them there. So it's popping with a lower voltage. Here we go, full voltage. Volume up. Tuning. stick a different tube in. I'll go back to the original one. Don't expect any change here. So what I'm trying to do right now is watch the DC voltage on the plate to see if it collapses during the noise. The noise has gone away. Why have you gone away, noise? Something is warmed up just enough? Come on. Isn't that something? You know, when I'm reaching for the cold spray, things are getting really desperate. Oh, there's almost no spray in here. What would I spray? Anyway, what would I spray that would never see this noise on the grid? Always see it on the plate. There's nothing here for me to spray. Spray the... oh, my sprayer's broken. How am I supposed to spray it? Okay, what we'll do is we'll spray the base down here. Why not? I heard something there. Oh. It's a little interesting. As if the cold finally got far enough to do something. Let me try the grid terminal here. I don't know if you can hear it, but there's a quiet hum in there. The hum is popping up and down also, not in accordance with the noise. Okay, I'm going to spray the detector resistor here. I replaced the detector and the capacitor. You know what, I just... I think when I replaced the detector resistor and capacitor with a temporary version here, still heard the clicking and popping. I never fully disconnected this. I disconnected this lead. I left this connected here. So it seems strange to me. I mean, on the grid here, we're seeing none of this staticky stuff. My thinking is static signal on the grid is very hard to hear and see. Maybe it is there. The tube is amplifying it. We can hear it when it's amplified, but beforehand I'm just not. I can't believe it. I put my my tracer right on this. Some weird stuff going on here. Cold solder. What if it's cold solder right in there? What if it's just a cold solder connection? What if that is all this is? Let us find out. I have no clue what else to go after here. So what I was muttering about was earlier I replaced the capacitor and the resistor here with an alternate. I soldered it here kind of lightly, ran the radio, it still clicked and popped. I disconnected this wire and hooked it up to this alternate resistor. I then concluded that the clicking and popping continued, so it can't be due to this. But I left this connected. Even though this end was disconnected, I left this end connected. Well, let's just resolder this stuff here and see what happens, because has anybody got a better idea at this point? Maybe you do. Maybe you do have a better idea. Fortunately, what's in your head is not in my head here, so we're going to go ahead and do this. A long shot. There we go. It's going to melt this whole thing here. It's a lot here to melt. Small modern soldering irons are not so happy about these huge clunky connections. Come on. Trying to get the main thing to melt here. There it goes. So this is really a tab coming off the capacitor, and the resistor is soldered to this tab, and then probably the resistor wire continues on through the tab and down to the terminal. Let's do one at a time. Let's not do the whole thing here. So I give this, like, you know, a 2% chance of fixing my problems. 2%, worth a try. 2%, that's an exciting rate of interest in savings accounts these days. Okay, that's all we need there. I will now try this other terminal here. I suppose, you know, there's a good chance that if the problem is in this area, that doing this kind of thing may really just make it worse, not better. But Worse would be a little hard to figure out here. Why exactly would, pulling the tube out and hearing it go silent is a little confusing too to me. Yeah, I would think there's some kind of problem in the socket. Pulling the tube out doesn't get rid of it, unless the problem is on the grid. But then you'd think you'd see it on the various tests I've done. Okay, here we go. Another run. Give it another run. Another run here. Yeah. Let's poke around with this some more. It's fun. There are lots of changes in this radio. I don't know if you're listening to that speaker. Okay, first we're going to start right over here where the signal's leaving the radio heading for the amplifier. Other side of this coil. Back over here. Don't go away. Don't go away, man. Come on. Don't go away. Okay, on the grid. Listening with audio on the grid. Okay, so the static you're hearing is coming out of the radio speaker. Listening with RF on the grid. So there's no noise on the grid that matches what we hear coming out of the speaker there. Nothing. Okay, stupid things. We'll listen to the heater. Just a hum. And the other side of the heater. How can it be any different? Louder hum. Cathode grounded to the chassis. Okay, it just makes my signal tracer go silent. Huh. Let me freezy the coil here. Freeze them up. I can't imagine that. I don't know if that's even effective doing it like that. It seemed to cause a change on the. I got very little of this cold gas left here. Come on, keep popping. And I've also left this capacitor connected here, thinking that it would be harmless. I still think it's harmless. This is a ground connection here. I think it's harmless. Oh! Wow, what was that? Seemed like while I was spraying it was noisy. Wow. Where are you coming from? Because all the mechanical things I do seem to have no effect on it, it suggests it's inside a component. This guy gets his B+. Pull the tube out, you don't hear the crackling. It's its B+ from its own winding, I think. Pull the tube out, it goes away. If the noise was in the B+, wouldn't it... if I use an alternate power supply here and try to power the plate of this tube from an alternate source, in order to remove it from the power supply that somehow is conveying this noise. Check the B+ on this guy. Should be around 40 volts. .45 volts. You can't see it, but it says 45. 45. Well, I can certainly supply an alternate. I think I can. I don't know about certainly. I think I can hook up an alternate power supply here and energize that tube. To think about that a little bit. And the crackle's gone. Nope. Is it inside this cable? The happiest sounding thing, eh? This is a hum control. Okay, I'm totally stumped. I don't know. I don't know. Okay, we're gonna leave it at that. Me not knowing. I don't know. What an annoyance. Okay, sunny day, I'm going out there. And rest my poor brain cells, what few are left after this. Crazy situation here. I'm back to thinking it's the socket again. Something dramatic has to be done here to break the impasse I'm at. I think I'll go sit in the sun. We'll see you in the next video.